thing. But I've got nothing to fight for.
Greetings, cadets. In this next segment, we're going to take the Starship Blink sketch one step further. We're going to add a warp fade effect to an LED, which could eventually be included in the deflector dish of a Starship. So this is a twofold lesson, as we'll learn how to use the Arduino's pulse width modulation pins to create the fade effects, and we'll learn how to incorporate a button into our sketch, which will allow us to interact with the circuit directly. So, without any further ado, let's get cracking. In this segment, we need the following components. As usual, we require a breadboard, an Arduino Uno, and some jumper wires. Similar to the Starship Blink sketch, we will be using a white LED for the strobe light and a green LED for navigation lights. The green LED needs a 100 ohm resistor, but the white one is connected to pin 13, which already has a built-in resistor. To change between warp mode and impulse mode, we use a simple momentary button switch. When the button of the switch is not pressed, no current flows to the Arduino's input pin, so the input pin is in a low or zero state. However, when pressed, a current flows to the Arduino's input pin and places it in a high state, which is indicated as the digital value of 1. In the sketch, we can read the button state from the pin and then specify an action within the sketch code. The switch itself needs a 10 kilo ohm resistor, or 10K for short, in order to function properly. For the actual fade effect, we will be using a 3mm blue and yellow bicolor LED. This is the best type of LED to use when finally incorporating it into a Starship's deflector dish. It has a common cathode or negative leg, so depending on which of the two positive legs receives a current, the same LED will light up either yellow or blue. The common cathode also needs a 100 ohm resistor. If one doesn't have a bicolor LED available, the circuit can still be tested by using regular yellow and blue LEDs, each with their own 100 ohm resistors. Unfortunately, these LEDs don't fade quite as smoothly as the bicolor LED, but they will be good enough to demonstrate the pulse width modulation. To start off, we need to unplug the Arduino from the computer or any power source. This is merely an extra precaution to prevent damage to the Arduino board. Our first task is to make sure the breadboard has power once the Arduino is plugged back in and the sketch is running. To do this, we need to focus for a moment on the Arduino's power pin array. In fact, we need to take note of two particular power pins which will be vital to the sketch. These pins are the 5V output pin and the ground or GND pin of the Arduino. We need to connect the ground or negative rail of the breadboard to the ground pin of the Arduino. In order to supply some current to the breadboard, we need to connect the 5V pin from the Arduino to the positive rail of the breadboard. Once the Arduino is plugged into a power source again, the various components we add to the breadboard will have ready access to the power rails. For the strobe light circuit, we connect pin 13 of the Arduino to the positive leg of the white LED. The longer leg of an LED is the positive leg, while the shorter is the negative one. We connect the negative leg of the LED to the ground rail of the breadboard. Similarly, for the navigation light circuit, we connect pin 12 of the Arduino to the positive leg of the green LED, and we connect the negative leg of the LED to the ground rail of the breadboard using a 100 ohm resistor. Next, we add the blue and yellow bicolor LED. The negative leg is the long one, unlike regular LEDs where the negative leg is the short one. Before we add the LED to the circuit, it is important to know which of the two outer legs cause the LED to light up yellow and which one blue. The quickest way to test this is to connect a 3-volt battery between the negative middle leg and one of the two positive legs of the LED. It's always handy to store a 3-volt battery with your LEDs, as it allows you to quickly check if an LED works before adding it to a circuit. As a note of caution, however, these batteries need to be kept well out of reach of small children. Besides being a choking hazard, they become highly corrosive in the body and cause serious tissue damage which could prove fatal. We connect the negative leg of the LED to the ground rail of the breadboard with a 100 ohm resistor. Before we connect the positive legs of the LED, we need to take a closer look at output pins 10 and 11 on the Arduino board. We notice that both of these pins are designated with a squiggly line in front of their pin numbers, which tells us that these pins are capable of pulse width modulation. This means they can simulate analog pins, because they can hold any value from 0 to 255. 0 will turn an LED off, and counting upwards will make an LED glow increasingly brighter to the maximum brightness value of 255. This effect will be ideal for us to fade between impulse and warp modes, and adds a seriously cool factor to any Starship build. We connect pin 11 to the blue side of the bicolor LED, and pin 10 to the yellow side of the LED. Our momentary button switch needs to straddle the divider of the breadboard. This is to ensure that no power flows through the switch unless it is pressed. We connect the positive rail of the breadboard to one of the legs of the switch. It's important to note that power flows diagonally across a switch, so the negative part of the circuit needs to be connected to the leg of the switch which is diagonally opposite to the positive one. To the diagonally opposite leg we add a 10K resistor and complete the circuit by connecting it to the ground rail of the breadboard. While the switch is not pressed, no current can flow. As soon as the switch is pressed, however, current flows from the Arduino through the positive rail of the breadboard, over to the switch, diagonally across the switch, over the resistor, to the ground rail, and back to the Arduino. This is fine and dandy, but we still need to let the Arduino know that a switch has been pressed. To do this, we define pin 1 as an input pin in our sketch and add another connection from the switch's output leg to input pin 1 on the Arduino. Now when the switch is pressed, we have yet another current flow through the circuit, this time from the positive rail of the breadboard to input pin 1 of the Arduino. Pin 1 is grounded internally. We may ask, why is it necessary to have the first part of the circuit if the reading is actually coming via the second part of the circuit? And why do we need such a high value 10K resistor as part of the circuit? The short answer is, the switch will not function properly otherwise. The 10K resistor is a pull-down resistor. Its functions are twofold. Firstly, it prevents a short circuit in the Arduino. Without the resistor, we would be pumping 5 volts directly back into a pin which normally functions using millivolts. This might cause the Arduino to short circuit. Luckily, the Arduino has a built-in fail-safe for exactly such a situation, and the board will simply power down and reset the sketch. However, this also means that our sketch will not function the way we want it to. The second reason for having a pull-down resistor is that it removes electrical noise from surrounding circuits, such as the strobe and nav lights and internal Arduino circuits. The pin establishes a baseline reading when the Arduino starts up, and any changes to that baseline reading are interpreted as the switch being pressed. If it picks up random noise while establishing its baseline, it won't be able to tell whether the switch has been pressed or not. We can try an experiment once we've set up the circuit to remove the resistor. we will most likely notice that the fade effect keeps activating itself without the press of a switch. Garbage in, garbage out. As a bit of advice, however, we should not actually press the switch, because that would send a lot of juice to our poor Arduino and probably short-circuit it. Alternatively, one can replace the bicolor LED with yellow and blue LEDs. Simply connect pin 11 to the positive leg of a blue LED and the negative leg of the blue LED to the ground rail of the breadboard with a 100 ohm resistor. Similarly, connect pin 10 to the positive leg of a yellow LED and the negative leg of the LED to the ground rail of the breadboard, also with a 100 ohm resistor. Now that the circuit has been put together, we need to download the Starship-02 sketch. The link for the sketch is in the description of this video. We simply right-click the link, select Copy Link Location, and paste it into our browser window. We click the download button and save the file to our Arduino working directory. Once downloaded, we open the Arduino GUI program. We click on File and Open and select the Starship-02 sketch. The GUI will warn us that the sketch needs to be inside a folder. We click OK to create a folder. At this stage, we need to plug our Arduino into our console. Before we upload the sketch to our Arduino, we click on Tools to make sure that the board we have selected is the Arduino Uno and that it is on the correct COM port. Finally, we click Upload to send the sketch to the Arduino. For the sake of filming, resistors with a higher value than originally suggested were used. This is merely because the LEDs were way too bright for the camera and needed to be toned down. We notice a small delay before the deflector dish fades on. This is to give the impression that different parts of the Starship power on at different times. It just looks a bit more real that way. Now, whenever we press the switch, the bicolor LED fades down and then fades up with its other color. In essence, we can switch between impulse and warp mode at the touch of a button. Alternatively, we replace the bicolor LED with blue and yellow LEDs. We plug in the Arduino and see a similar effect, where the strobe and navigation lights start blinking, followed by a deflector dish yellow fade up. Then we press the switch, the yellow LED fades down and the blue LED fades to full brightness. Unfortunately, the effect is not as smooth as it is with the bicolor LED, but it does give an indication that the circuit is working. Who would have thought that creating such an awesome warp fade effect would be so easy? The Arduino is incredibly versatile. Now, if only we had some phasers and photon torpedoes. So long, and thanks for watching.